Hello friends. So today we'll discuss the pressure inside the liquid droplet, show bubble and liquid jet. So in previous lecture we see that the every area is converted to the spherical area because of surface tension. So here, so there is any area, so there is any liquid are there, and due to the surface tension, due to the so here there is a liquid molecule are there, and due to the surface tension of this due to the surface tension of this in each molecule, due to the surface tension, so they try to decrease their area, and we know that the spherical have the lower area, so so it is converted to a spherical shape. Okay, so this is the spherical shape. So here is the molecule. Okay, so and here there is a surface tension, sigma is acting in that way. Okay, so another case is that if the curvature, so here the curvature is like this. Okay, so if the curvature in that way, so if you see that the curvature in this here, so here pressure, consider this is P1, and here this pressure, that is P2. Okay, so P1 is greater than P2. Okay, for that case, that is P1 is greater than P2, because the curvature here, the curvature inside this curvature means there is a pressure is large, this large compared to this. Okay, and if the curvature is straight line, okay, so here the pressure, inside pressure is equal to the outside pressure. Okay, so this pressure P2 and here pressure P1, so in that case pressure P1 that is equal to P2. Okay, and suppose if the curvature in this way, okay, so here there is a pressure, there is a, consider this is pressure P2 and this is pressure P1, so P1 less than P2, so P2 pressure is larger because the curvature in this side, okay, curvature in this side, so P2 is larger as compared to P1. Okay, now we will focus on the liquid droplet. So first case that is liquid droplet. So the liquid droplet, that is the shape of the liquid droplet, and if we cut the cross section of this liquid droplet, so here this will be the cross section in that way, so this is the cross section. Okay, and here there is a pressure, consider this pressure is P, and outside this pressure, that is atmospheric pressure, PATM means atmospheric pressure, and consider the diameter of this sphere, that is small d. Okay, this is the diameter. Okay, and the surface tension is acting in this way, so here there is surface tension and this is surface tension, so sigma, and there is a pressure force is acting in this way, so pressure force, so this is the pressure force, so pressure force denoted as Fp. Okay, so so here there is a pressure force is acting, so Fp is acting in this way, and there is surface tension force is acting here, this layer, there is surface tension is acting here. Okay, so if you want to calculate the excess pressure, So if you want to calculate the excess pressure that is delta P. So delta P is the, so what is the largest pressure? That is P. So P minus P ATM, atmospheric pressure. Okay, and if you want to calculate the pressure force FP, that is equal to delta P into projected area. So here, what is the projected area? So if the diameter is this, so what is the area? What is the area? Pi by 4 d square. This area is the pi by 4 d square. So if you want to calculate this, delta P into pi by 4 into d square, we know that area that is equal to pi r square. So r equal to d by 2, so pi by 4 d square. Okay, and if you want to calculate the surface tension force Fs, that is sigma into L. We know that surface tension force that is equal to sigma into L, sigma into pi into d, that is circumference. So what is the circumference of this? 2 pi r or pi into d. So pi d is the circumference. Okay, so here sigma is the surface tension. Fp is the projection force. Okay, that is projection force. Ap, that is the projection area. Delta P is the excess pressure. So delta P is the excess pressure, or you can say pressure difference. Okay, so pressure difference. And Fs, that is the surface tension forces. So this is the surface tension force. Okay, so when in equilibrium condition, the pressure force must be equal to the surface tension force. So what is the pressure force? That is delta P into pi by 4 d square. So delta P into pi by 4 d square, that is equal to Fs, that is sigma into pi into d. So from here you can calculate that delta P, that is equal to 4 sigma by d. So this is the very important formula for GATE, ESC, SSC, JEE, ISRO, DRDO, BARC exam. Very important. So if you want to calculate the pressure difference, just 4 into multiplied by surface tension divided by area and divided by diameter. So this is the main formula. Okay, now this delta P. Okay, so we see that delta P, that is equal to P minus P atmospheric, atmospheric pressure. Okay, so from here P equal to delta P plus P atmospheric pressure. Okay, so from here P equal to delta P. What is the value of delta P? That is 4 sigma by d, plus P atmospheric. So here this pressure is known as absolute pressure. So this is known as absolute pressure, and this is gauge pressure. This is the gauge pressure, and this is the atmospheric pressure. Okay. So this is all about the liquid droplet. Okay, now we will focus on the soap bubble. So next, that is second, soap bubble. Soap bubble. For soap bubble, so how the soap bubble look like? So this is the inner layer and this is the outer layer. So here inside that this is air, and outside there is air, and inside that there is a liquid. Okay, so consider this outside diameter. So inside diameter is equal to outside diameter. So consider di equal to outside diameter, that is d. So di is the inside diameter, inside diameter. Do, that is outside. So this is the diameter. Okay, so here this is the diameter. So this is the outside diameter. Okay, outside diameter, outside diameter. Okay, so if we focus on the cross section XX, if we focus on the cross section, this cross section, so what the soap bubble look like? So this is the soap bubble look like. Okay, so this is the soap bubble look like. Okay, so here this is pressure P, and outside this pressure atmospheric pressure, PATM. Okay, and the pressure force, that is AP, that is projection force, that is also known as projection force. So this is the AP, and the surface tension is acting in this layer also, so in this section also and in this section also. So surface tension here, this is surface tension is acting in that way also, and here also. So this is sigma, 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 sigma. So here also sigma. Okay, so for equilibrium, so in equilibrium condition, what is happen? We know that pressure force, that is the surface tension force. So what is the pressure force? That is delta P into, what is this area? Pi I 4 d square. So this is the pi I 4 d square, and surface tension force, so for this case that is equal to pi sigma into pi into d. So we know that the inner diameter, that is equal to outer diameter, that is the average diameter. Okay, d is the average diameter. So here this surface tension, because of two layer, so from outside sigma into pi into d, plus for inside sigma into pi into d. Okay, so from here you can calculate that delta P into pi by 4 d square, that is equal to 2 pi sigma into d. Okay, so from here you can calculate that, that is 2 pi sigma into d divided by pi by 4 d square. So from here delta P, that is equal to, so d 1 d cancel out, pi cancel out, so this is equal to 8 sigma by d. So 8 sigma is the surface tension, d is the diameter of the soap bubble. So this is very important for GATE, ESC, SSCJE and other competitive exam. Very important relation. Now the third case, that is the liquid jet. Okay, so the third case, that is the liquid jet. Liquid jet. So consider there is a nozzle, and from this nozzle the water is coming in this way. Okay, so consider this is the cross section. So here pressure, that is P, here there is atmospheric pressure, P atm. Okay, so if you want to calculate delta P, so what is this case? So P minus P atm. Okay, so here so if you draw this cross section here, so this is the cross section, and here there is a P is acting, and outside that is the P atm. Okay, and if you focus on the another one section of this this liquid jet, so here so this is, consider this is the diameter, and here here the AP, that is projection forces. AP is acting in this way, and surface tension force is acting here, sigma, and here also surface tension force. Okay, and so what is the pressure force? So what is the projected force? AP. So AP, that is delta P into projected area. So what is delta P into projected area? That is L into D. So consider this is the length L. Okay, so this is length L, so L into D. L into D is the projected area. Okay, and if you want to calculate the surface tension force Fs, if you want to calculate the surface tension force Fs, that is equal to sigma into L, and here also plus sigma into L. That means this is the surface tension is acting only in this this line. Okay, so sigma into L, and sigma for this line, that is sigma into L. So that is basically 2 sigma into L. Okay, so this is 2 sigma into L. So if you want to in equilibrium case, this is pressure force, that is equal to surface tension force, and from here you can get delta P, that is 2 sigma by D. So this is very, very important. Remember this very, very important formula. Thank you.